So here we are again at the Kerbal Space Station. It's now night and we're ready for mission 3 of the career mode. So this time we are going to take a Kerbal and we're going to send him up and we're going to make him orbit the moon. So we're going to go into our center here. We're going to use some of the nice parts that we just researched. Actually, let's, for reminder's sake, just take a look at the research center to see what we've got to work with at the moment. So we got the standard propulsion units here. All of this was in the first. We got this. It has significantly a little science unit here that allows us to collect more data. We then got a aerodynamic stability part, which now has rail decouplers in it, and we got this with the Rocco Max solid fuel boosters, and we've got these separators, and we've got, very importantly, a thrust vectoring engine. So, using these supplies, we're now going to take one of our brave astronauts and send him around the moon. Just going to look here in the center here for astronauts, and this guy doesn't look too bad. We can check that guy too. This guy also looks great, so what I'm going for is actually people with a little low stupidity. Actually, previously I had one of the more stupid guys, Jebediah Kerman, on a trip to the moon and let him circulate that. So we're going to go in and we're going to build a new vessel here, which is going to be a moon orbiter, and we're going to go with the standard setup here. Small part, parachute on top, and this time we're going to do it right and make decoupler right under this, so that we can decouple in the middle of space. And we're going to attach our scientific equipment also, which is a small antenna, and the goo observatory, because of course we want to observe some goo when we're going to the moon. We're going to attach 2 of these to make it symmetrical. So there we have it, a small observation pod here, and the idea is to this we're going to attach a rocket that is going to be able to send us into the direction of the moon, break us down, put us into moon orbit, and put us out of moon orbit again and back to the home planet. So what we're going to do is attach some fuel, and now we got some pretty big fuel canisters here, so we're going to take 2 of these big ones, because that should be enough. And then to make this easy to control, we're going to use the new thrust vectoring rocket here. We're going to put one of these here. So this is our final stage, and we're going to add to that a decoupler at the bottom here. And we're now going to build a stage that's going to lift us up, and maybe perhaps we should have between here a stage that's supposed to control our direction and put us into a good wide orbit. And what we want for that is actually just one of these big ones, and a thrust vectoring rocket here again. I think actually we should take yes, the thrust vectoring rocket. I don't know if we're going to be able to lift all this with just one of these rockets, but I guess it will, since it doesn't have much fuel. Actually, we should be pretty high above atmosphere, so in order to just have enough fuel for this, let's add 2 stages of this, like a similar stage to our last stage, and add a decoupler here. And then let's clean up these stages, because we want this to decouple and burn at the same time, we want this to decouple and burn at the same time, we want this top decoupler as a last, and then when we decouple that we enter atmosphere, and we want to separate the parachute and capsule. Yeah, so we got everything here. Now we're going to make some big lifting rocket here, and the big lifting rocket is going to consist of 3 of these big tanks. It's going to have a thrust vectoring engine in the middle. And now we're going to play with some of the new stuff, because we now have this radial decoupler. We want to put 6 of those in, pressing X here to take that up, and we want to place those, I think. Actually, let's build one of these first. Let's put it here, and then just attach one of the solid booster rockets here. Put that a little bit lower down, like so. So that's a serious solid fuel booster we got here now. And if we take that off and then press X to duplicate that 6 times and put it back on, it gives us a nice spread here of 6, and put that so it matches. Not quite. We need to go further down. Like that. Yes, that's actually pretty perfect. Now we got one engine in the middle, thrust vectoring enabled, controlling this, these 6 solid fuel boosters, which is capable of lifting the entire aircraft. And just for fun's sake, and to make these solid state boosters fly away from the spacecraft, we're going to add some of these jettison parts, turn it the right way, and put that up. No, it's not possible. Put it about there, and we're going to put some in the same position on the other side to make it go away from the spacecraft when we activate this. Actually, I think we should move these a little bit up so they don't hit each other, and because that could make it explode big time. So that's gonna rip off these solid booster rockets here, and we want this to go with the separation stage up here. So all these little boosters down here, they go up to this level, which you two, and big booster rockets, and the last stages of the separators go up here too. That goes up here too. So now at the bottom we got big solid fuel booster rockets, and I guess this is the center rocket. Let's just take a look if that lights up. Yes, that's the center rocket. We want that down here. So let's go through the staging. We burn all the engines at the bottom. When the solid fuel rockets are spent, we clip those apart with this, using the separator engines here. Then when that stage is burned, we separate the craft down here with a separator, and then activate this engine, and then we correct our orbit, and then set us into the right orbit, and then we use this last one to have us go with the last stage of this thing, which is the one that's going to go to the moon. So we haven't tested this yet, so I have a way of naming things that, if they're not tested yet, I call them prototypes. Prototype. So this is going to be a prototype moon, because it's not the moon in this game, it's moon. So we're going to name it prototype 1, and then we're going to save it, and then we're actually going to do the crazy thing and launch this big rocket into space. See how it handles and how far we get. Oh, nice nightly launch. We're going to do this standard thing. Check that SAS is on, throttle up to 100%. And then this is Jebediah Kerman going into moon orbit. Mission launching in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, launch. Nice acceleration. This is looking promising. Good direction. Still meters per second. 5 kilometers, 280 meters per second. Nice acceleration. 6 kilometers, 7 kilometers, 8. We're going to have to wait until the solid state boosters are burned out before we can correct the direction. Burn up there. Separation. Nice with the separator rockets. And we're going to correct the orbit here. We have 50% fuel on the last lifting rocket, which is just about keeping us at the same acceleration speed. So actually this is lifting our rocket pretty well at the moment. I'm going to go to map view to check, and we are approaching a 26 kilometer apoapsis. But actually at this stage this engine should already have burned out, so all this boosting right now is just a bonus. So that tells me that we are most definitely on the right path here. And the second stage of this rocket is burned out about now. Separation. Second engine boosting us way past 500 meters per second. 34 kilometers in height. Our apoapsis is quickly climbing now. 38, 39, 40. Our apoapsis is now at 50. It's climbing really fast now. 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70. So now we're into space, and we'll go a bit further than that. Let's gather some good speed here. Let's use this rocket for going towards Moon a little bit more. That's 100 kilometers. Going to stop right there. Going to set our target for Moon. Set as target, and we are going to, I think we're going to need to burn about here. So let's add this up. Oh, that's completely wrong. It's not going to have us hit anything like the Moon, because the Moon is way over here. We're going to actually burn through the Earth right now, so we're going to need to correct a little bit here. And we're going to make ourselves go into a high orbit here, because that's always good. So we're going to use the last of the booster rocket to take us into that high orbit. And approach the blue mark here, thrust vector mark. 18 seconds to burn. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, burn! And separation, burning last stage. So this is actually what this stage was meant for. It's taking us out of orbit. First of all, we need to make a high orbit here. Obviously, this is surprising how little fuel we're going to need when we're approaching the Moon, because the Moon has no gravity, and what we're doing right now is just getting rid of trying to exit Earth orbit at the moment. Let's delete that point. And I think we're going to need to throw that right about here to make us hit. So, going up here, circling around until we catch this thing. There we go. So, not needing that much throttle. Let's cut back again until we need it at the slightest, smallest point here. Let's turn it a bit over balance this out nicely. So that's about it. We're going to use most of Moon's gravity to pull us back towards ourselves. So, like that, hitting the moon. Maybe we can go a little bit down here to make it low up a bit. Hitting right about there. So that takes us pretty close to the moon. And this point, and we're going back to the camera view, live camera view. We're going to turn around and find this point, and we're going to see we need a 32-second boost to get up there. And pointing in the right direction, accelerating time. 11 minutes to go. 10, 9 minutes, 8 minutes, 7, 6, 5, 4, 3, 2, 1. Decelerating time. 0 minutes, 50 seconds, 40 seconds, 30. Decelerating 2 times 1. Burning 30 seconds. Go. 10 seconds to burn. 5, 4, 3, 2. Initiating burn. Full power burn. Yes. And then we're going to go to the map view and control what's the vector here. And we're going to be ready to throttle down when we are approaching this vector from the orbit, and throttling down, and cutting. So this is not actually enough. We're going to hit the X mark here again, and we're going to correct a correcting burn here, throttling up. This orbit that we're hitting right now actually has us brake and return back, so this is actually a huge fuel saver at the moment. So this is actually a much better vector than what I was able to create. So I think we should keep that and then go to the moon this way. And let's just check that we don't have any silly height problems here or something. And let's delete that vector and let's just fly this path. Now, at this stage we're going to go all the way up to time accelerating times 1,000. And we are approaching moon gravity well, which stops here. This is moon encounter. Let's take the time down to times 50 here. And then funny things start to happen once we hit this gravity well here, because then all navigation starts to reference from the moon, and that's going to make an orbit like that, because we're now referencing to the moon. And we are going to brake when we hit this point, so actually let's go down to times 1, and let's put a maneuver in right here, a braking maneuver. So we brake it down, no, not hitting the moon, that's crazy. Let's just put a little bit more power like that. The less I have to brake, the more power I have to make the return to Kerbal. So and this will take us 1 hour to reach this maneuver point. But we're not going to do that. We are going to time accelerate. And we are going to time accelerate times 1,000, and we're going to hit it right there. 5 minutes. 4, 3, 2, 1. Slow this down to 1 and maneuver our ship. Actually, this is close to retro vector, so let's go to that. Right there. And we still have plenty of time to do the burn. Adjust this navigation point. Actually, I like to do these navigations from out here on the map view because you can see the trajectory, and it gives us a little bit more information about how we're going to hit the orbit. And that is actually nice to have. So, 6-second burn in 20 seconds. Crosshairs on here. 10 seconds to burn. And we're going to burn slowly this time because out here it doesn't really take much to slow anything down, so slow this down. The burn point, and we're going to wait for this vector to come down and hit an orbit around the moon. Wait for it, and we now have an orbit, and we now have an orbit of the right size, right there. Cutting engines using X, and then we can delete maneuver point, and we're now in a moon orbit. So we still have plenty of fuel to make it back to out of moon orbit, and Jebediah Kerman is quite happy. And we want to take a crew report now because he might have something to say about being in the moon orbit here. When you look down at the cold grey surface, it looks really beat up with craters. It has a scientific value of 15, so let's keep that plan. And let's try to observe the mystery goo. That has a scientific value of 30. We want to keep that instead, so we go ahead and keep that. And let's do some orbiting and wait till we are at the periapsis here, because then Jebediah might have something else to say about the moon. Actually, moon orbits are really slow because the gravity of the moon is just so weak. So, Jebediah, what do you have to say now? Crew report. Override the existing crew report. Yes. The inside of craters might be good. Yes, we want to keep that report instead. Or actually, we want to beam that report back to Earth, right? Override that. We can get 100% if the transmission works. Let's extend this antenna. Yes, and let's communicate that back to Earth. Yes, 15 science points for communicating that. And let's take this crew report and keep that data. Let's review these data. The goo feels right home here. We got another 30 points for that. Let's keep that. Okay, mission accomplished. Now what we're going to do is reset this goo canister, and we're going to go up to the map view, and we're going to at the apoapsis here. We're going to add a vector here that's going to take us out of moon orbit. We're actually currently in reverse orbit now, so right about here should be the right point. So let's go to turn 1, put a new point in here, and then let's put in something that's gonna take us in a flat trajectory like that. Because we're in quite a steep trajectory at the moment, so this is going to take us directly in direction of Kerbal. I actually think that's going to make us hit it, but who knows? Who knows? We're heading pretty much in the right direction, aren't we? Actually, this thinks we're going to enter into some strange orbit here around the sun in the end. I don't really think so. I don't really think so. Well, we have 2 hours to wait until this burn, and we're going to go back and see that it's just a 12-second burn, and we have more than enough fuel for that. Some serious time acceleration here, 2 hours, 1 hour, 0 hours, 50 minutes, 30 minutes, 25. Okay, let's go to 1 and put the spacecraft in the right orientation. You can see the burn vector marker is down here. So when falling back to Kerbal, we're going to gain quite some speed. We're falling into the gravity well of the planet, so leaving moon air doesn't really take a lot of power. So there we have it, all just about, and accelerating the time, 15 minutes, 14 minutes, 13, 12, 10, keeping an eye on this. 7, 6, 5, 4, 3, 2, 1 minute, slowing down, 2 times 5, going back to the map view. We want to burn from in here to check we're hitting the vector. 50 seconds, 30, 20, going back to 1 times accelerating, ready for the burn in 5, 4, 3, 2, 1, initiating burn. Ready to cut the throttle here. And cutting throttle. Back to the view here. We still have enough fuel for correcting the orbit. So now we're going to wait to we are exiting the orbit here. And time accelerating for this. Going out here. Then we have to correct our orbit to go towards planet Earth, and the earlier we do it, the better. So we have to do something like this. And we have to scrape. We want to save fuel, so we just barely want to scrape the atmosphere here. And we want to make the atmosphere the thing that's dragging us down. So an abscess of 18,000 meters. That's fairly good. That's going to take us inside the Earth's atmosphere and just make it a little bit lower. That was too much. 10 kilometers, that is fairly okay. We're going to go back. We're going to hit our vector here. And it's a 20-second burn. He's not going to make that. So actually right now I think we have Jebediah Kerman caught in space. And we have no docking ports, so there's no way of intercepting Jebediah Kerman when he sort of flies by planet Earth. That's quite a big problem. But we will have to at least try to do this right, and we can hit the planet surface. So at some point in this mission we must have used a little bit too much fuel, or propellant, as they want to name it when it's in rocket science. 40, 30, 20, 12, 11, 9, 8, 5, and it was 2 seconds. We went to Russia and we went to full burn, and that was it. That's not nearly enough. That is actually taking us into a horrendously big orbit around the Sun. So how we're going to get Jebediah Kerman out of that situation, I don't really know. I guess we're going to call this a failed mission for Jebediah Kerman to orbit the moon and back again. And I think we're going to press escape at this moment, and we're going to revert the flight, and we're going to go back to the vehicle assembly and look at what was wrong with the rocket. I am going to end this recording here and do another attempt after redesigning this rocket slightly. So thanks for watching.